Okay, now we're talking about limits at infinity. So the question is, what happens to a function as x gets either increasingly larger, more positive, or x gets increasingly smaller or more negative? Okay, so this is the concept here that we are going to be taking a look at when we analyze these functions that we're looking at right now. So by definition, a horizontal asymptote is defined by a limit approaching infinity. So this one right here, it says a line y equals b is a horizontal asymptote of the graph of a function y equal f of x if either as x goes to infinity, the limit as x goes to infinity of f of x equals some number b, or as x goes to negative infinity of f of x, it equals to some number b. So this is the calculus definition then of a horizontal asymptote. In pre-calculus perhaps, or a college algebra course, you might have defined it a different way, but this is at the heart of that pre-cal definition that probably wasn't mentioned before, but now we're going to get into it. So I use kind of a trick in order to analyze these, and I think it just makes it so nice. So what I'm going to ask you to consider is this mnemonic device: Bobo Botno eats DC. Okay, Bobo Botno eats DC. What in the world is that? Well, when you're looking at rationals, at rational functions, and that's what we're taking a look at in the examples we're going to work out right now, if the exponent is bigger on bottom, so suppose, I don't know, you have x squared over an x cubed plus dot dot dot, okay? This exponent here, 3, is bigger than the exponent here, 2. So what I would tell you here is that the limit for this would go to 0. All right? So bigger on bottom, 0. Okay? If it's bigger on top, suppose it was the other way around, x cubed plus dot 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 over an x squared, something along those lines, then we might say that the limit does not exist, and it actually will go to one of the infinities. Okay? But again, we're going to say does not exist for right now. We'll talk about which infinity in another video. If the exponents, the leading coefficients exponents happen to be the same, so let's say we have, I don't know, 2x squared plus something and 3x squared plus something, it's a rational. If the exponents are the same, this means divide the coefficients. Divide the coefficients. Okay, that's what it would look like. Divide coefficients. So the coefficients here are 2 over 3. And so then the limit here would be that the function is going to this number, suppose 2/3. So we're going to use this concept for limits. All right, this kind of mnemonic, Bobo Botno eats DC. Again, bigger on bottom, it goes to 0. Bigger on top does not exist. That's what that no means. All right. More specifically, later on we'll discuss that it goes to either positive or negative infinity, or both perhaps. And then if the exponents of the leading coefficients are the same, we divide the coefficients. Okay, so let's take a look at this one. We're looking here, and I see that we've got a rational, but down here in the bottom is really the only place that we have an exponent. And so it's 6 over x squared. What would apply here to that little piece? Bobo Botno eats DC. Okay, Bobo Botno eats DC. This one would be Bobo. And I put this 0 with the line through it, so you know it's a 0. That means that this right here is going to go to 0. All right? So what are we left with then? We are left with the limit as x approaches negative infinity of 8 divided by 8, which is just 1. and the limit of a constant is the constant itself. Okay, but let's think about it in a different way. If I were to have said plug in negative infinity, for example, so 6 over negative infinity square, and this really is not what you're supposed to do, but I'm just wanting you to think about it. Okay, so if you have 6 divided by negative infinity squared, well, the negative infinity squared becomes positive infinity, right? So suppose you had $6 and you want to divide it by, I don't know, 1,000,000,000,000 people. How much would each person get? Virtually nothing. They'd get 0. Okay, so that's where you end up with this, and you just divide 8 divided by 8 because that's what's left, and you get 1, and the limit of a constant is the constant itself. Okay, so that's the way that you would approach this. All right, now let's go ahead and take a look at this next problem, number 2, and give me 1 second here to pull it back up. There it is. All right, if you look at this one again, now we've got 2 little things that we're looking at. All right, what happens on the top? Okay, it's bigger on the bottom. Bobo again, Bobo. And on the bottom, it's also Bobo. If you're looking at those little things in isolation, okay, it's the same thing. All right, so what ends up happening, this goes to 0, this goes to 0. We're looking at the limits of these things independently, but now we're left with this constant -4/6, which tells me then that the limit as x approaches negative infinity is of the number 2/3, -2/3, which is just -2/3, because the limit of the constant is the limit of any constant really is the constant itself. Okay, now that's not too bad. We're going to take a look at number 3, which is quite similar to what we just did. Okay, now I'm going to show you a couple of ways that you can approach this. The real easy way is Bobo Botno eats DC. So let's take a look. We're going to analyze here the leading coefficients, the leading terms rather. Okay, so in this case we have x squared over x cubed, and this one again is bigger on the bottom. So long story short, this limit is going to be 0, just like that. Okay, just like that. But you know, that's with this sort of trick. You know, I'm going to go ahead and show you what actually ends up happening. You end up having to divide out everything by the largest exponential power that you have. So it actually looks something like this. The actual work of it would be something like this. Now, if Bobo Botno eats DC works for you, you stick with that. Okay, it's relatively easy to figure out that way. But what we're going to do is divide all of this in the numerator and all of this in the denominator by the largest exponential power, which is x cubed. Okay, so let's do that. 8, I'm sorry, it should be x cubed again, plus 19 over x cubed divided by x cubed over x cubed plus 3x squared over x cubed plus 18 over x cubed. Okay, looks something like that. Now you could use some formal rules of algebra to simplify this. The limit as x approaches infinity, in this case x squared over x cubed, when you use powers from algebra, that's 1 over x, and subtract 8 over, in this case, x squared plus 19 over x cubed. That doesn't change. The denominator, x cubed over x cubed, that's 1, plus the 3x squared over x cubed becomes 3 over x, and then plus 18 over x cubed. Now we can say plug in this infinity. Okay, we can plug in this infinity. All right, again, it's not really what we do, but I mean, it's what I want you to think about doing. Okay, maybe not mathematically sound of an idea here, but say you have $1 and you're dividing it by 1 billion people. How much does each person get? Relatively nothing. And let me actually change color here. 0. What about $8 divided by 1,000,000,000 people squared? Again, relatively nothing. Same thing goes for the 19. Relatively nothing. All of these end up going to 0. And you end up with something that's like 0 divided by 1, which is just 0. But of course, way back over here, we knew that was going to be the case because we used a little shorthand trick. All right, our mnemonic, Bobo Botno eats DC. Okay, we'll work out the very last problem here. Again, this one right here is kind of nice because the exponents are the same. So since the exponents are the same, we divide the coefficients, and this answer here is going to be whatever that divided by that is, and negative divided by negative is positive, so 11 out of 10 is the final answer there. But let's go ahead and prove it by dividing everything by the largest exponential power, which is x squared. So x approaches negative infinity, and we're going to have negative 11 x squared over x squared plus 2x over x squared plus 15 over x squared divided by negative 10 x squared over x squared minus 2x over x squared plus 18 over x squared. Something like that. Again, you use the rules of algebra. Very time-consuming work, if you ask me. I mean, if you figured out the mnemonic already, you probably have stopped watching the video. Negative 11 plus 2 over x squared plus 15 over x squared divided by negative 10 minus 2 over x plus 18 over x squared. Now, again, important to note, you're dividing by negative infinity and you're plugging it in. And I say that in air quotes, plug in. This one goes to 0. This one goes to 0. This one goes to 0. And this one goes to 0. All right? Because you're dividing, suppose 2 by negative infinity to the second power. Again, $2 divided by, I don't know, 1 trillion people, they're going to get nothing. All right? So all of these little things go to 0. And you're left with this right here, which boils down to a positive 11 out of 10, which we knew at the start was going to be our answer. Okay. I'm going to stop here. The next problem that you see there at the bottom will be part of the next video. So if this was helpful, as always, remember, like and subscribe.